Welcome, Maths. This is a short lesson to help you understand how we can use Desmos and linear equations to actually solve problems. And we're going to pick it up from where we left off last lesson, and that is trying to find a rule. So let's once again have a look at what a rule is. A rule is basically a set of instructions or an instruction to do something to a number and change it into another number. Now normally what we do, we call the number we're going to change x, and we're going to take that number, put it into our rule, and out will come another number. We're going to call that y. Now in most cases, well, actually, I'll say that again. Rules can be of many different sorts, but the ones that we're going to be starting with are probably some of the simplest rules, which are linear equations. An example of a linear equation rule would be something like this. Y equals 2x minus 4. So, what does this actually mean? This is the rule that tells us how we're going to change this x value into the y value. Now the x value can be any number we like. And so what we're going to do, we're going to pick a range of x values, and we're going to change them into their corresponding y values. So let's take some numbers, and I'll start maybe 0. I'll put the number 1 in there. 2, I might put the number 5, and 10. Okay? Let's see what this rule does to these numbers. So let's start with the first one, x equals 0. So in order to actually work out the corresponding y value for each x value, what we do, we simply write down our rule, which is y equals 2x minus 4, but we now substitute the value of x for the number we're plugging in, and in this case it's 0. So we're going to replace or substitute the value of x with 0, so it's going to be 2 times 0, I'm using brackets, and it's 2 times 0 minus 4, and so that equals 0 minus 4, which is negative 4. So when x equals 0, the y value that goes with it is negative 4. Let's try 1. So y equals, it's going to be 2 times, in this case, 1, not 0, because we're plugging the number 1 in. So 2 times 1 minus 4. 2 times 1 is 2, minus 4, which is negative 2. Now you can complete the others if you like, pause the video if you wish. Okay, welcome back if you paused, and I'm just going to quickly complete the others. So the third one, x equals 2, to be y equals 2 times 2 this time, minus 4. So that will be 4 minus 4, which is 0. And we can probably do some of those in our head. 5, when x equals 5, it'll be 2 times 5, which is 10. 10 minus 4 is 6. And if x equals 10, 2 times 10 is 20. 20 minus 4 is 16. And so there is our table of values that we've generated using this rule. Okay, this equation, which is the instruction for this rule. Now let's switch over to Desmos to see how this might work. So what I'm going to do, I'm going to create a table of values in Desmos. So in order to do that, and you can do this as well, is press on the little plus icon down here where it says table. And we're just going to enter our numbers 0, 1, 2, 5 and 10. So 0, 1, 2, 5 and 10. And the numbers that we worked out to go with them were -4, -2, 0, -4, -2, 0, 6 and 16. Okay, let's have a look. Okay, so we've got some points there. Let's zoom in on our graph a bit. Okay, well, I'm going to change the scale a little bit. If you need to change the scale, here's how you do it. Press on this little spanner icon, and you can change how the range of numbers on the y-axis and on the x-axis. I want to perhaps reduce the range here. I don't want to go up as high as 100 or down to a -100. So I'll go over here where it says y-axis, and I'll make my minimum y value much less than that. I'll make it -10, and I'll make my maximum y value, I'll make that 30. And that's looking better. And I might actually change my steps to I'll make them 5. No, wait, I'll make them 4. No, wait, I'll make them 1. Okay. Righto, so we can now see, hopefully, if we plot those points, notice they all form a straight line. They're in a straight line. So this equation, this rule, when we plot out the graph, it forms a straight line. That's why we call it a linear equation. So that's why these equations get their name. They're called linear equations because when we actually plot them out on a graph, they produce straight lines. Now, we can also use Desmos to predict or to confirm that this is the equation. Let's see how we might do that. So below, I'll just move my axes up a bit. I can just click in a square like that, and I'm going to write in what I think the equation is. It's y equals 2x minus 4. That's what we came up with. So it's y equals 2x minus 4. Well, look at that. The line passes through every one of those points. Not only that, but there's a whole lot of other points that we haven't plotted or that we didn't actually put in our table, but that still sit on this line. For example, the point 710 is on that line. The point 7.65, 11.3 is on the line. All of these points, and you imagine how long it would take to write down every one of these coordinates on a table of values. It would take forever, and even then you wouldn't finish. So to actually be able to sketch the linear equation is a very, very quick way of finding all the possible values that sit on that line. Okay, so let's try this again in a different way. So let's just summarize what we've learned. We've learned that a rule is an instruction that tells us what to do with a set of numbers and change them into another number. The numbers we take to begin with are what we call our x values, and the numbers we change them into are our y values. Okay, so we'll clear this. And let's do something a little bit different this time. This time I'm going to give you the table of values first, and we're going to see if we can work out what the equation is.